Is it working? That is the question of the day. Let me adjust my audio a little bit. And just wait for this to pop on the other side. In the meantime, hope you're doing well. Sorry for the weird schedule. Quick announcement regarding that. Let's see if this works. It's working. Cool, it's working. Quick announcement for schedule things. Originally, I was doing things on Tuesday. For the next couple months, I'll be doing these live streams later towards the end of the week. Most likely Thursdays, just like today, around the same time as usual, around 3 o'clock, 2 o'clock Eastern time. So we're going to jump in. There's some questions that I got over the week that I wanted to jump into, and there was part of that I was curious how exactly it worked. And then I'll also go into some setting up of MCUBoot for a board that didn't have it, and that would be one of these little handy little LoRa boards that have an ST chip inside of them. I don't typically use ST chips or any of these things, but this board has an overlay and a board definition in Zephyr, but they didn't set it up for MCUBoot, so I went ahead and did that. So we will be going over that in today's talk. So I'm going to jump over. And if you haven't already, please subscribe, hit that like button, and let me know in the comments if you have questions, if you have things that you'd like me to take a look at on these live streams. Almost all the content comes from everybody in the audience right now. So if you have burning questions about Zephyr, please send it my way, and hopefully I'll cover it in the next session. So. First question that came in earlier a couple days ago is from Shannon, and she said, "How do I assign a GPIO pin to some other task? How do I give it a logical name in an overlay rather than using the LED pin or the LED pin or LED definition?" And she also mentioned in her questions like, "Hey, I've seen people use this Zephyr, users overlay entry," and I said, okay, that might be doable. I actually haven't used that entry before. I've always created bindings, so we'll go over both, and you'll see which one might be better for your particular application. So two ways. You can create your own binding, and this will be living in this is specific YAML file that lives in your application or lives in a library. And then also we'll be going over using Zephyr user, kind of what I just mentioned. If you're using West, Zephyr will look for any bindings in a DTS bindings folder. So this might be at the root of your application. It might be in a module. So it looks in a couple of different places for this bindings folder. So the biggest thing here is just like naming it something that you can use, that you can remember and format correctly. So, for example, here's an actual binding file that I created for the NRF9160 Feather. It's using the company name, PSCTL, which is just power control. It's controlling the mode input on the power supply. So, and then it's a YAML file. Inside that guy, we have a description. We also have that compatible. You notice this compatible. This is the type of thing that also you will see in the overlay. You'll see compatible equals and then that name. We'll be using that shortly in the overlay. And then properties here. We are referencing a mode. We're just calling it mode-GPIOs, and it's just a handle array for GPIOs. And this is pretty standard for GPIO definitions. And I just added some descriptions and things that are nice to have when, if there's errors or whatnot. It kind of gives you more context. And here it is in the overlay itself. We're using that. We're giving a label as PSCTL. We're also just, its name is PSCTL. You see that compatible equals Circuit Dojo. And then we're setting we can have an array of GPIOs, but in this case, it was just a single one. So, and that is a cheap and easy way to not only get your custom pin defined in your code, but you can also reuse it, and that's kind of one of the main advantages. We'll go over that in a second. But here's the usage. For many of you guys who've watched my videos in the past, you've seen this type of setup where you're pulling all that information from the overlay, and then you are actually getting it using device.dt-get in your code. The lines underneath get GPIO and inside code will be in a function or whatever. So, and the rest of those macros will live outside your code. And we're in this case we're just pulling the GPIO 0 because we know that's on that port. And then we can just use GPIO pin configure, and then as usual we'll use the GPIO pin set, get update or change or set high, set low, so on and so forth. So setting an interrupt, things like that. So on the other hand, Zephyr Zephyr user is a great way you can add GPIOs on the fly, and especially for things that might just live in your application and might not live outside, or maybe for instance, like if you have a board specific GPIO that maybe you don't really care if it's there in other designs. Zephyr has some good documentation on this. I actually went through it before this video, and I've also included a link to it in the description. And we'll just go over the example there because I thought it was pretty handy. And like I mentioned before, if you want to reuse this on another board, if I can talk, you want to create your own binding like we just did earlier. So here's an example of using the Zephyr user, and they just created this array of GPIOs, so signal-GPIOs, and what the Python scripts and all the crazy magicalness that will happen in the Zephyr in the backend when you're compiling will actually kind of put two and two together and make this available to you in your code as a GPIO. And you'll see here's the C code example using that exact definition, and we're pulling in that Zephyr user node, and then we're getting the full device tree definition of the GPIO. I've never actually used this particular way of getting a GPIO, but it's kind of handy because it'll pull both the GPIO port and the GPIO pin in a single struct. And then you can configure it all at once, literally using 2 arguments instead of 3. And then you can set it using the set or get using the standard GPIO pin set get functionality. You just got to give it the port and the pin, and also like what level you want it to be at least for this set command. So that would be it for those 2 things, and you can see that one is a little bit more simple, but it kind of has to live with your application. It's kind of one-off, versus if you want to create your own bindings, especially for drivers and things like that. It's also very handy if it's something that you want it to live longer than your application, or you want to be able to port it to another device. So whatever you think is best for your application, and hopefully that should help for people who are wondering, how do I not use the LED definitions? Because I've used the LED definitions myself for creating just basic GPIOs. I was like, I just need this to work, just LED. But hope that helps. Shannon, and hey Shannon, I think this was your question. So can you cover GPIO versus GPIO controller 2? And not exactly sure what you're saying, but there are, you have the GPIO controller, or the port that belongs to the GPIO pin, and boards might have multiple GPIO ports. Typically, like on Nordic chips, the NRF91 only has 1 port 0. NR52 has 2, so 0 and 1. STM32 chips, sometimes, depending on how big they are, they actually use ABCD. So you might have, interestingly enough, even on a 64-pin chip, you might have port ABCD, but there might be just a couple select pins for each one. They optimize it so And the bigger packages, they're using all the ports and all the pins. That's the idea. So, but it's really specific to your board, and this might be something you have to actually look into the Devicetree bindings, the definitions for your board, to see what the name of it is, because I use GPIO 0 in this example, but it could be GPIO A, GPIO B, and I will show you that in this MCUBoot from scratch, because I actually had to use the different the port name for it. So hope that helps, but you can always send me a message, Shannon, or if you want to clarify what exactly you're trying to get at. Happy to explain it. All right, MCUBoot from scratch. So I was working on that board I showed you earlier, and turns out it didn't have MCUBoot configured. So when you build an application for it, it's just, it's starting at 00 in the in the onboard flash. So when it boots, it goes right to the application. For something that you might want to update over the air, then adding the MCUBoot is really handy. And we'll just jump into it. So, and not all boards in Zephyr, especially in vanilla Zephyr, kind of support MCUBoot out of the box. So we will set it up, we will update the configuration and overlay for the application. We'll update the configuration and overlay and add them if they don't exist for MCUBoot, which most likely they won't exist if it's not set up before. Compile and load the bootloader. Compile and load the application. Those are two distinct steps, and some of you who may come from using Nordic's NR Connect SDK, they actually do all of this for you behind the scenes. So they will compile both the bootloader and your application, merge them together, and then make them available to you. That's one realization I came to when I was trying to do this from vanilla Zephyr, not using any of NCS, and I was like, wait, why don't I have what I'm expecting here? And that's because Nordic has taken the time to figure out how to get all that stuff where it's merged together for you automatically on the back end. You don't even have to worry about. In this case, you actually have to build the bootloader separately and the application separately. You can always merge them together manually, but you can also just flash the bootloader and then load your application using UART or whatever method that works on your board. So many of you, if you used MCUBoot before, this config _bootloader _MCUBoot, that is the guy to turn things on. In vanilla Zephyr, you also have to set the signature key file, and this one is just using the one that comes with Zephyr, the default one. For secure applications, I recommend you don't use this, because anybody can push code to your device because you use the default key. So make sure you don't do that. And on NCS, this is filled by default to use the same value. So, and so here we're doing the application side just to start. And in this case, this board had a storage partition defined. And what you need to do is define the partitions correctly for MCUBoot to work. So what I'm doing here is setting the partition that is expected to boot, and also all the other partitions that are available. I kind of explained this in previous shows, in previous live sessions, but MCUBoot has, if you're doing it all within the same flash, then you'll have a primary and a secondary partition. So if you're uploading or updating your device, it will leave the current running one alone and actually write the application to the secondary. And then when it reboots, it'll kind of swap them over. Also, some interesting things you'll see in a second is that there's also a swap space, and also if you want to, you can actually add some user space for writing and reading configurations and things like that, even data values. This is hefty, so I try to fit it on one slide because you can kind of see the whole thing, but it might overwhelm you at first. Underneath these guys right here, we're just setting up the partitions as I kind of mentioned. You have a boot partition, which is what I didn't mention this, but that's where MCUBoot will live. This is a little bit bigger than the size of the MCUBoot that I actually ended up compiling. I think it was like 68 kilobytes, something like that. So this is a little bit bigger, but that's fine. You can always tweak these as you go. But what you see here is this reg equals for each one is the start position and then how big that partition is. So if you look at the boot partition value there, you'll see that it goes to hex 10,000. You see the next one, it starts at hex 10,000 and then the size is 16,000. You can see it kind of increment up. So when you add these together, do a little math. When you add the first number to the second number, that should be the start of the third of the next one down. You just want to make sure everything is contiguous so you can use all your space as needed. But you can see we're starting the boot partitions at the beginning. You have slot 0, slot 1. Those are where the app is going to live. You have the scratch partition, and that's used by MCUBoot to do any transfers. I believe it will actually transfer. It either will just boot to that particular area in Flash, either the secondary or primary, or I think it actually will swap over from secondary to primary and boot from there. So I think it's the latter. And also for the for storage, you can use that storage _ partition there. And you can see everything's contiguous, everything's set there, and you just got 2,000 hex as the size. So, and that goes all the way to the end of the Flash, and Flash is 40,000 on this particular chip, which is 256 kilobytes, I believe. So that is all this stuff would normally go in like a linker file for people who are coming from outside of the Zephyr ecosystem. In this case, we're using the Devicetree to actually define where these partitions live. I find it particularly a little bit more intuitive and a little bit easier to work with. But I've also been working in Zephyr for 2 years plus. So your mileage may vary, but hopefully you can take these examples and you could always, there's tons. All you have to do is open the SDK and just find something that is using the bootloader and look at how they managed it. I actually went through, because this is an ST chip, I went through and actually looked at all the other boards that are ST, that had that ST prefix to see if they had MCUBoot configuration configured, just so I could see how they did it. And it's a great way to learn. That's just looking at what other people have done by example. It's great. So this is pretty much it for the app side, and then we'll just conclude. What we'll have to do is also add these configurations and overlays for MCUBoot itself. MCUBoot, in this case, you can think of it as a separate application. You're going to be compiling that application just like how you would compile any other Zephyr application. And we just need to add a board-specific configuration and a board-specific overlay for that particular application. So, and one thing you will have to do is if you're using vanilla Zephyr, you have to make sure that you include MCUBoot in there, or else you won't be able to build any MCUBoot things. And I'll show you the overlay and what needs to be added. So here's a vanilla Zephyr definition in the manifest, in West manifest. And you can see at the bottom there, you just got to make sure MCUBoot is added. And that will pull it into the bootloader -MCUBoot folder. And here is, so this would be living in, I think I had it in the previous slide here. So you can see located in bootloader, MCUBoot, boot, Zephyr, and boards towards the middle of the screen there. That's the kind of the path. So this is actually the board.conf, whatever the name of the board is. In this case, we're disabling the console. We don't want that mucking with MCUBoot. And we're setting up, in this case, it's a serial setup. So we're going over your UART. So we're setting that serial to Y. And then in this case, because we were using a button to actually activate the, put it into, so hitting the reset, or holding the button, hitting the reset pin will put it into bootloader mode, essentially. And I also added an indication LED there on the board because it had one, and it's very useful to know when the board is in bootloader mode. So very handy. And then a lot of these, and then you just do this config underscore size optimizations, and that will help keep it small, and then you can kind of reduce the size of your MCUBoot partition if you need to. So handy. Here is a overlay, and it's in two parts. This is kind of the beginning of the file, and the second part is actually the same Flash configuration I showed you before. So you can see the storage partition. I have removed it because that was like a default in the original Devicetree bindings. Also, you have to make sure that you set the Zephyr UART MCU manager to whatever UART you're using for your device. So in this case, I've set it to USART1. It might be different on your platform. On Nordic, they use UART 0, 1, 2, 3. In this case, on STM32, it's called USART. So a little bit different, but same thing. Oh. And also, because we are using the LEDs, I turned it on in the configuration. Just got to define it. So the bootloader -LED 0. And this is actually by looking. So this guy right here is actually looking at the board definition in Zephyr and then finding out what the LED, what the name of it or what the label of it is, and then creating that alias. Because that alias is then used in MCUBoot. And that's some code that actually contributed to the MCUBoot project, which is very cool. It's cool to see other people using it. And go back. Here is that Flash definition again. Nothing's changed here. It's the same exact thing. So the biggest thing here is make sure it matches your application overlay, and this matches. Or you can make sure that the board overlay or the board definition files, the DTS files, have this in there correct. And if you have the ability to update that information and push it to the Zephyr project as a pull request or something, that would benefit the whole community for sure. So, but if this is kind of like a one-off thing, maybe it's just not something that gets pushed up, then you just got to make sure those are the same, or else you'll run into problems for sure. Here is the build process. So, like I mentioned before, you need to build it. You'll need to build your MCUBoot. You have to build your bootloader and your application, and program them kind of separately. So here's from the root directory. So you're in the directory that has the bootloader folder and the Zephyr folder. So we're building from there. So we're setting the target directory as the MCUBoot directory. We're setting the board name. In this case, it was called the LoRa E5 dev board. And then importantly, you have to make sure you include this DTC overlay file and reference this LoRa E5 dev board overlay, and that will make sure that that overlay is included in the build. And that's the overlay we just went over. So, and this will generate a file in the build Zephyr folder, and that is the build Zephyr folder is wherever you're currently. So if you're on the root of your project, it'll put that build folder within the root of your project. There are some other ways where you can redirect it and put it in different places, but in this case, for simplicity's sake, it's just put there in the root. If you're building an application, most likely you'll have a separate build folder within the application folder. So, and then that turns into it will be a zephyr.hex file. Ooh. Yeah, in that build Zephyr folder, it'll create a zephyr.hex, and that will be the file that you need to load using whatever tools you're using. For Nordic, it's NRFJProg plus whatever deb board that you have that can do that can program SWD. For ST, it's the ST-Link and the ST-Link, the command line utility, the ST-Cube command line. And I was using that to program this particular bootloader to that device. So, yeah, it depends really what platform you're using to program that bootloader. And so we've already configured the application, so we're going to build it as we've done before, either West Build, or if you're using like a plugin or VS Code, you can build it that way. And it generates if you have that the PAM file, the key set in your configuration, it will automatically sign your application. If you've used Nordic stuff before, you get that app_update.bin. That's pre-signed for you. In this case, West will pre-sign using that key if it's defined in your configuration file, which is handy, but it uses a different name. This one is zephyr.sign.bin, and you want to make sure that you're using that file. It won't generate a bin file if you don't have that key set in your configuration. So, and I found that out the hard way. So review. So you can create your own. This is for review for everything. If you create your own, you can create your own binding for something that you think it's going to live for a longer time. Maybe you're going to use it across different boards, or you can use that Zephyr, user compatible, and it's really up to you and how you think it'll work best for your application. But there are a couple choices there, which is awesome. MCUBoot can be added to most boards. Even if it's not defined by default. As you saw, it's a little bit of tweaking, adding that flash to 0, all those entries in Flash, and also just the configurations on both your application side and MCUBoot. So 2 places. And make sure that you do that, and then also you're going to be compiling and loading them separately. Now there are some ways to merge those hex files together. And I wonder if there's a way to script it, but there is a way to script it because Norik did it. But you can also merge them together if you want, if you have a preference on that and you just want to do everything in one shot. So that is also an option. And let's see. But that is it. Let's see. I'm going to check one thing. All right. I do have some comments. So we'll jump into those and then we'll call it a day. Is it possible? So, Combat Team, is it possible to use MCUBoot with USB CDC instead of UART? I believe so. There are some options in MCUBoot for using USB CDC. It depends on if your board in Zephyr supports USB, but I have seen it before. I haven't played with it much, but I believe it is possible. So you might have to look into it a little bit more for your board specific device, but I think like if you're using the NR52 or 53, it's most likely supported. So, but don't quote me on that. Franz, good to see you. I noticed a LoRa definition in your YAML file. Does the STM board you have use a Semtech device, and are you running LoRaWAN on it? All good questions. So this is an interesting part because it actually has. They basically licensed Semtech's IP and they merged it into one piece of silicon. So it's an SoC plus radio. So they're communicating via whatever internal UART or whatever to that Semtech IP. It's basically just taking that Semtech chip and putting it inside an STM32. So that's how they're doing it. And then the cool thing is that there's some great support in Zephyr. I haven't played with it too much, but it exists, which is nice, for connecting a client to a LoRaWAN network. The only downside is what I've seen so far is there's client support. There is no gateway or host support on the other side. And that's probably because it's just like more complex and crazy. I'm used to Bluetooth where you can create you can create a Bluetooth device that can be a server or client. Doesn't really matter, and you can just set it up and it's done really well. But for LoRa, it's actually like different radio architecture for the gateways where they have multiple, like 8 stacked receivers, 16 stacked receivers or whatever that are all listening at the same time. So that's the only downside that I found so far, which is a bummer because I was hoping to use Zephyr for both. Have you used that at all? So for LoRa or USB CDC, I have not used the MCUBoot UART or MCUBoot via USB. I have not done that so much. I've pretty much done that always over UART because I'm using chips that mostly have UART. But for LoRaWAN, I have set it up here, and I've been able to get the MCUBoot working on these chips, these STM32 modules, and I haven't been able to connect anything because I don't have a LoRaWAN gateway. I used to, but I don't have any. I got to get another one. So Let's see. Cabot team, unfortunately, it's custom STM32F7 board, so I'll have to dig deep, I suppose. Yeah, so for the USB stuff, you might have to look into it a little bit more. And most likely, I know ST does support Zephyr in many ways, so I wouldn't be surprised if they have the USB implementation working for their chips on Zephyr. So I know MCUBoot has some amount of USB support, so hopefully you'll find something there. And then Zephyr and GPIO. Let's see. Is MCU... Another question for Cabot team. Is MCUBoot UART compatible only bootloader? Is it possible to use radio transport, Bluetooth or cellular, or would it need pretty much custom bootloader? That's a great question. The nice thing about Zephyr, batteries included. So if you're using Bluetooth, there is a pre-configured basically an MCUBoot characteristic service that you can use to update your device over the air. It already exists, or already works. It's great. For over-the-air updates for the NRF9160, Nordic has some firmware over-the-air update support that you can set up on your device if you want to, and it works very well. I've been using it for 2 years now. For other boards, your mileage may vary if you are using some type of cellular board, but the inner hooks do exist where you can kind of roll your own if you need to. So the nice thing is you don't have to create your own custom bootloader. It's stuff that needs to be done on the application side. So everything that I've mentioned, all the support, either Bluetooth or LTE, all that is on the application side. So you can roll your own application side bits that actually work with the MCUBoot, put the data where it needs to be in the secondary partition, whether or not be in internal flash or external flash, however you have it configured. But yeah, you don't have to mess with the bootloader, which is very, very nice. It's just like compile it, set it, and as long as you have those the way it is set up in the overlays that I kind of described earlier in this live session, should be good to go. And it's up to you on how you get that how you get updates into your in your partitions. So let's see. That's it for the questions. It looks like. Dun, dun, dun. I think that's it. I'll give it a minute. But that's it for today. And if you haven't already, please do subscribe, leave a message, let me know what you think. If there are things that you'd like to see me do in the next live session, please let me know. If you missed it at the beginning, I am switching over to Thursdays around this time every week. I do have some conflicts on Tuesdays, so we'll be doing these on Thursdays going forward for at least the next couple months. And that's about it. And if you haven't already subscribed to my mailing list, it's at jaredwolf.com. I do send out little reminders before every live session if you use email in your inbox all the time. So I will. That's it for now. Thanks for being here, and we'll see you in the next one.